Good afternoon, everybody. How are you? Hello, Dhruvi. Well, anyways, I think you have taken a note not to speak anything. So, in the previous sections, we have covered uh, all the basics of this uh, basic maths, I should say, law of indices, factors, log, and we have covered certain things. So today we are going to start with a new chapter, that is quadratic equation. All right. This is also an important chapter, an important ingredient for so many chapters. And this is nowhere like too much in the NCERT also. So we will focus on it thoroughly. It's a very important chapter, will be used every here and there again and again. All right. So here in this chapter, we'll do how to form a quadratic equation using sum and product. We'll do location of roots, graphs, and signs of quadratic equation, relation between roots and coefficients of higher degree polynomial equations. All right. So first of all, what is a quadratic equation? An equation of the form of ax square plus bx plus c. An equation of this form ax square plus bx plus c, where a not equal to 0 and a not equal to 0 and abc are constants, some constants, then we call it real quadratic equation. Here ABC are called the coefficients of the equation. Now with coefficients, extra we do is A is what? A is leading coefficient. Leading coefficient. And the C is called absolute term. Absolute term. All right. The quantity D equals to B square minus 4AC. The quantity D equals to B square minus 4AC is known as the discriminant of the equation this AX square plus BX plus C equals to 0, and its roots are given by this. Got it? I'll give you its proof also. Say we have AX square plus BX plus C equals to 0. Now, with the method I'm going to tell you, also understand how do we complete the square in case of a quadratic equation. So, first of all, make the coefficient of x square as 1 or minus 1. So, if I take it a common, it will be x square plus b upon ax plus c upon a equals to 0. Got it? So, what did I do? After making the coefficient of x square as 1. After making the coefficient of x square and as 1. Now add and subtract the coefficient, add and subtract the square of half of coefficient of x. Add and subtract the square of half of coefficient of x. Now coefficient of x is what? B by a. Square half of this is b by 2a. And then square of this is b square upon 4a square. So you add b square upon 4a square, subtract b square upon 4a square. Now what is this? This is a times x plus b by 2a whole square minus If you take LCM in the rest of the terms, it will be b square minus 4ac upon 4a square is equals to 0. Am I correct? So this x plus b by 2a whole square is equals to plus minus under root of b square minus 4ac upon 4a square. You remove this square, you took it to the right side, it will become under root and plus minus will come over there. Got it? So x will be what? X will be minus b plus minus under root of b square minus 4ac upon 2a. Now this b square minus 4ac is what? Discriminant of the quadratic equation. So with this you will say x is minus b plus minus b plus minus under root of d upon 2a. Am I correct? So this is how we got this thing. Have a look at it. Look at it. Note it down. All right. Now, so the term this is the quantity b square minus 4ac, which is d, is known as the discriminant of the equation this. And its roots are given by minus b plus minus under root d upon 2a, which I also calculated right now. Got it? An equation of the form az square plus bz plus c equal to 0, where a, b, c can be complex numbers, is called a complex quadratic equation, and its roots are given by same minus b plus minus under root d upon 2a. Am I clear? Now see here. What are the roots that you figured out? Roots are minus b plus minus under root d upon 2a. Tell me one thing. If this d goes positive, okay, I am assuming that a, b, c, they belongs to real number. Now, if d is more than 0, you are going to get two distinct real roots. There will be two distinct real roots. Like for example, if I say x square minus 3x minus 2 equals to 0. So what will be x? X is minus b means 3 plus minus under root b square 9 minus 4, a is 1, c is minus 2 upon 2. So what do you get? 3 plus minus under root 9 and 8 17 upon 2. So these are the two roots that you got. Am I clear? Now, if this d goes 0, then there will be two repeated roots. If this d is 0, there will be two repeated roots. Got it? So two repeated roots stands for, like if you have a quadratic, because see now the roots will be minus b upon 2a and minus b upon 2a. Like you have x square minus 2x plus 1 equal to 0. So x will be what? X will be minus minus plus 2 plus minus under root of 4 minus 4 upon 2. It will be 1 comma 1. So in this case, quadratic equation generally becomes a perfect square. So in this case, quadratic equation, I should not use the word, I should use the word expression. Quadratic expression becomes a perfect square. Am I correct? Now, if d is less than 0, then there will be two imaginary roots. If d is less than 0, there will be two imaginary roots. For example, x square plus 3x plus 4 equals to 0. Now x will be what? Minus 3 plus minus under root of b square 9 minus 4ac 16 upon 2. So it is minus 3 plus minus under root of minus 7 upon 2. So that is minus 3 plus minus under root of 7. This under root of minus 1 is iota upon 2. Got it? So in that case, we have two imaginary roots. So this is the point they are explaining here. If ABC belongs to real number A not equal to 0, then the equation has distinct roots and real roots if D is more than 0, has real and equal roots if D is equal to 0, has complex roots with non-zero imaginary part if D is less than 0. Got it? So now relation between roots and coefficients. Now see one thing, let me prove it for you. Say you have a quadratic equation ax square plus bx plus c equals to 0. Let its roots are alpha and beta. Now there is another quadratic, I write say x minus alpha, x minus beta equals to 0. Now definitely its roots are alpha and beta, that is quite visible to us. That means this ax square plus bx plus c equals to 0 and x square minus alpha plus beta into x plus alpha beta equals to 0. They are equivalent quadratic. Or I should say same quadratic, as simple as that. Now if you compare both of them, then 1 upon a will be equal to minus of alpha plus beta upon b is equals to alpha beta upon c. So from this alpha beta is minus b upon a and alpha beta is c upon a. Got it? Now say a simple question I have for you. If there is a quadratic 2x square plus 3x minus say plus minus 5 minus take it 6 equals to 0. Got it? 2x square plus 3x minus 6 equals to 0. Let us assume its roots are given to me as alpha and beta. Now, first question is find the value of 2 minus alpha, 2 minus beta. Second question, alpha square plus beta square. Third question, alpha cube plus beta cube. Fourth question, alpha cube beta plus beta cube alpha. Find these values. Yes, give it a try quickly. Take your time. Take 2 minutes. Yes, I think you have tried it. See, first of all, for the first question, just see a way how can we write a quadratic. This 2x square plus 3x minus 6 can be written as 2 times x minus alpha x minus beta. Both are having same roots alpha and beta with the same leading coefficient 2. Got it? Now, to get the value of 2 minus alpha, 2 minus beta, put x as 2. So twice of 2 minus alpha, 2 minus beta will be 8 plus 6 minus 6. This is 8. So 2 minus alpha, 2 minus beta will be. Got it? Now, in the second question, they're asking for alpha square plus beta square. So this alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. Now you have sum of roots, that is minus 3 by 2. You have product of roots, that is minus 3. So minus 3 by 2 whole square minus 2 times minus 3. You got the roots? Now the third question, if I talk about, it is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. You have sum of the roots, you have product of the roots. If I place, sum of the roots will be minus 3 by 2 whole cube minus 3, product of roots is minus 6 into alpha plus beta is minus 3 by 2. Right? So now I think you can manage. And here, if I take alpha beta common, it will be alpha square plus beta square. Alpha beta you are already aware of. That is minus 3 and alpha square plus beta square we just calculated in second part. Am I clear? Now, these same things they have mentioned here. If alpha and beta are the roots of quadratic equation, ax square plus bx plus c equal to 0, then sum of roots will be minus b by a and product of roots will be c by a. Also, this ax square plus bx plus c equal to 0 is equivalent to a times x minus alpha into x minus beta. Now about the cubic we will talk about later on. Got it? Now, common roots. Now suppose the quadratic equation ax square plus bx plus c equals to 0 and a dash x square plus b dash x plus c dash equals to 0. There are two quadratic equations. Now let us assume they have one common root. Now if they have one common root, this is the condition we are having. Now how did we get this condition? See, one quadratic equation is ax square plus bx plus c equal to 0. Other is a dash x square plus b dash x plus c dash equals to 0. Now, for the first equation, first of all, let alpha is the common root. So it will be a alpha square plus b alpha plus c equals to 0 and a dash alpha square plus b dash alpha plus c dash equals to 0. Now multiply this quadratic with a dash, multiply this quadratic with a. So you get a dash alpha square plus b a dash alpha plus c a dash equals to 0. This is a dash alpha square plus b dash a alpha plus c dash a equal to 0. Now you subtract both of them. This is cancelled. So it is b a dash minus a b dash alpha is a c dash minus c a dash. Got it? So alpha value you get, this is a c dash minus c a dash upon b a dash minus a b dash. Now, this is the common root which I obtained. Now you place this alpha in any one of the quadratic. I place it in the first equation. So it will become a times a c dash minus c a dash upon b a dash minus a b dash whole square plus b times a c dash minus c a dash upon b a dash minus a b dash plus c will be a c dash minus c a dash upon b a dash minus a b dash is equal to 0. Now you multiply this equation by b a dash minus a b dash whole square, you will get that condition. Got it? Now there is another way of Cramer rule also. You will get the same relation from there again. Like a simple question, if I ask you, say we have a quadratic x square plus bx plus c equals to 0 and x square plus cx plus b equal to 0. Now these two equations, they have a common root. Find the value of b plus c. They have a common root. Find the value of b plus c. Just give it a try. Now see, let alpha is the common root. So it will be alpha square plus b alpha plus c equal to 0 and alpha square plus c alpha plus b equal to 0. If I subtract both of them, this alpha square will cancel. So you get b minus c alpha plus c minus b equal to 0. So what is the alpha that you got? That is b minus c upon b minus c, that is 1. So 1 is the common root. 1 is the root of both the equations. You place this x alpha equals to 1 in any equation. So 1 plus b plus c equal to 0. So value of b you got as b, c plus b you got as minus. Am I clear? Now, got it? Now just try a few questions over roots of a quadratic equation. Have a look. First of all, go with question number 1. Alpha, beta are the roots of this quadratic. Gamma, delta are the roots of this another quadratic. Find the value of alpha minus gamma, alpha minus delta. Yes, please. How do we do it? Yash, Prusti, Dhruv, can you speak? See, first question I'll do for you. Alpha, beta are the roots of first quadratic, isn't it? And gamma, delta are the roots of second quadratic. Means x square plus px plus r equals to 0, having roots as gamma and delta. So this x square plus px plus r can be written as x minus gamma and x minus delta. They're asking for alpha minus gamma, alpha minus delta. Now in this equation, put x equals to alpha. So alpha square plus p alpha plus r is alpha minus gamma and alpha minus delta. Now x square plus px minus q. X square plus px minus q equal to 0. Its roots are alpha beta. So alpha is one of the roots, means it will satisfy. So alpha square plus p alpha minus q equal to 0. So that means alpha square plus p alpha is q. Put this alpha square plus p alpha here. So alpha minus gamma into alpha minus delta is q plus r. Q plus r. So this is your correct answer. Have a look. Now, give it a try for second question. Third question. Then. Third question is a nice question. Just quickly try, everybody, please. Now see. The second question is alpha beta are the roots of this equation. Find the value of 2 alpha minus 35 whole cube, 2 beta minus 35 whole cube. See, if alpha is a root of this equation, that means 2 alpha square minus 35 alpha plus 2 equals to 0. That means 2 alpha minus 35 is minus 2 by alpha. Similarly, 2 beta minus 35 is minus 2 upon beta. Now, if I place these values here, what do I get? Minus 2 upon alpha whole cube minus 2 upon beta whole cube. That is 64 upon alpha beta whole cube. Now, product of root is 1. So, answer is 64. That's it. So simple it is. Now, this is a nice question. Third one. A certain polynomial px, while x belongs to R when divided by x minus b, x minus c, leaves remainder a, b, c. Okay. See. They are saying when Px is divided by x minus a, then we say remainder is Pa. If you guys remember, we have done this theorem in 10th class also. So when this Px is divided by x minus a, remainder is a. That means Pa is a. When divided by x minus b, remainder is b. When divided by x minus c, remainder is c. So when we divide this Px by x minus a, x minus b, x minus c, there will be some remainder, some quotient qx. Now, if you are dividing a polynomial by a cubic, remainder will be quadratic plus a. Let us assume remainder is ax square plus bx, or let us take abc are already there. Let us take it as lx square plus mx plus. So whenever I divide a polynomial or a higher degree polynomial by a cubic, possibility of remainder is up to quadratic. Now put x equals to a. So PA will be LA square plus MA plus N, and this is given as A. Put x equals to B. So PB will be LB square plus MB plus N. This is given as B. And if you put x equals to C, PC is LC square plus MC plus N equals to C. Now you have to solve these three quadratic equations for, this is even not even quadratic, three these linear equation, three equations for L, M, and N. Got it? You solve these three linear equations. If you solve them, you will get value of L as 0, value of N as 0, and value of M as 1. So remainder will be what? X. All right, take a look. Done? Now, okay, one more concept I need to tell you. Now see, a quadratic is having two roots. All right. And it is a quadratic because coefficient of x square is non-zero. So ax square plus bx plus c equal to 0 is a quadratic as a not equal to 0. So this will be having maximum two roots. Sometimes they may say this equation, this quadratic equation is having infinite number of roots. So whenever they say that the quadratic is having infinite number of roots, means it is an identity in X. It is an identity in X. And in that case, A will be 0 as well as B will be 0 as well as C will be 0. And then every value of X will satisfy this quadratic equation. Every value of X will satisfy this quadratic equation. Got it? So now A0, B0, C0. See, there is a question like fourth question. this a square minus 1 into x square plus a minus 1 into x plus a square minus 4a plus 3 is an identity in x. Then what will be the value of a? So to make it an identity in x, you will have to find that a at which coefficient of x square is 0, coefficient of x is 0, constant is also. Got it? So now what? To make it an identity, a square minus 1 should be 0. That means a is plus minus 1. This coefficient of x, a minus 1 should be 0. That means a is 1. This constant should be 0. A square minus 4a plus 3 equal to 0. That means a can be 1 or 3. So a equals to 1 is the only value at which all the coefficients are getting 0 simultaneously. So that a equals to 1 is your answer. Got it? Now, try for question number 5 and 6. Very good questions. Go for it quickly. All right. So the fifth question is, for what value of m this equation will have equal roots? So for equal roots, what do we do? For equal roots, its discriminant should be 0. Isn't it? So simply what do? You find the discriminant of this quadratic equation and make it 0. So the equation is x square minus 2x times 1 plus 3m plus 7 times 3 plus 2m is equals to 0. So d will be what? D is b square minus 4ac. So this is 4 times 1 plus 3m whole square minus 4a1 and c is 7 times 3 plus 2m. You have to make it 0 to get the value of m. So 4 cancel. It is 9m square plus 6m plus 1 minus 14m minus 21 equals to 0. So it is 9m square minus 8m minus 20 equals to 0. Now this is 20 into 9. 20 into 9 means 180. Factors of 180, which when subtracted get 8. That is 10 and 18 and 10. Yes. So 9m square minus 18m plus 10m minus 20 equals to 0. So it is 9m m minus 2 plus 10 times m minus 2 equal to 0. So 9m plus 10 into m minus 2 equal to 0. So value of m is 2 or minus 10 by 9. That's it. This is what you were expected to do. Got it? Now, the next question is, again, a very good question they're asking. If PQR are odd integers, then prove that this equation roots cannot be rational. Now see, for the roots to be rational, what do you want? You want D to be a perfect square. Correct. So if D will be a perfect square, it will come out of under root and will make the roots rational if PQR are rational. Got it? So what you have to do, you have to show that the D in this case can never be rational. Yes or no? So the question is like, say, px square plus qx plus r equals to 0. Now its D will be what? Q square minus 4pr. Let P is 2p plus 1, Q is 2q plus 1, and R is 2r plus 1. They are perfect squares. No, sorry, odd integers. Now check for D. D will be q square. So that is 2q plus 1 whole square minus 4 times 2p plus 1, 2r plus 1. Am I correct? Now it is 4q square plus 4q plus 1 minus 4 times 4pr plus 2p plus 2r plus 1. So, mm, 2q plus 1 whole square, roots cannot be rational. Roots cannot be rational means D cannot be a perfect square. To show that this D cannot be a perfect square, okay, let's take it in another way. Yes. Now it will be quite easy. Let us assume that this D is a perfect square. Say it is some h square. That means q square minus h square is 4pr. That means q minus h into q plus h is 4pr. Correct? Now, if q is odd, definitely h will also be odd because this 4pr is going to be even. So if they both are odd, then this is going to be even and this is also going to be even. Yes or no? Q is odd, H is also odd. So let Q is 2Q plus 1 and H is 2H plus 1. So this will be what? 2Q minus 2H and this is 2Q plus 2H plus 2. This should be 4PR. Now if I take 2 common, this 2 will cancel. It will be Q minus H and this will be Q plus H plus 1. This is PR. Yes, so now see, if this Q minus H is odd, this Q plus H will also be odd. If Q minus H is even, this Q plus H will also be even. So in any case, if Q minus H is odd, then this combined Q plus H plus 1 will be even. If this Q minus H is even, this is Q plus H plus 1 will be odd. So in any case, this left side is going to be even. This left side is going to be even, whereas this right side is going to be odd. So left side going to be even, right side going to be odd. So this quadratic, this cannot happen. So the assumption we assumed is wrong. So the quadratic cannot have all You cannot be have the rational roots if PQR are all. Got it? So it was a tough treat. This question was little difficult. Rest we have done it quite a justice with the chapter, and you just practice it more from any of the source you guys are having. All right. So let's call it an end up to this point. Now I will ask you for a small feedback about the class. So just